Hello, Big Reds. This is part two. What do I need to know to get an A on the exam? So pay close attention, take notes, and listen. We'll go where we left off at. This problem right here, we want to know what x is. So this is opposite, and this is hypotenuse. So that's SOH, S-O-H, because we have an O and an H. So we take the sine, S stands for sine of 53 over 1 equals O over H, so it'd be x over 18. Numbers on the bottom, so I multiply, cross multiply. Take 18 times the sine of 53, and you get x is approximately 14.4, and that's your answer. All right, next one. Ooh, this is an interesting one. This is the hypotenuse. This is the adjacent, but that's not what makes it interesting. What makes it interesting is we got to solve for that angle right there. So in order to do that, we're still going to use SOHCAHTOA. We're going to use trigonometry. We have an A and an H, so that's cosine, ca. But instead, when I'm solving for an angle, I have to use the inverse, cosine -1 of A divided by H, or 5 divided by 17. So to do that in my calculator, I press second cosine, then 5 divided by 17 in parentheses, and I get approximately 72.9 degrees. All right, let's keep it rolling. Next one. All right, so here we want to find the angle of elevation from the runway. This is our theta. This is opposite. This is hypotenuse. So we have an O and H, that's sine, but again, this is another one I'm solving for the angle, so I have to use the inverse sine. So sine -1 of O over H, 1200 divided by 4000. And let me do that in my calculator. So I press second sine, 1200 divided by 4000. And I get about approximately 17.5 degrees. Okay, next we have some vocabulary from Unit 6. So in a circle, DF, the chord going through the center of the circle, this is called a diameter. Okay, DE is going from the center of the edge of the circle, that's called a radius. DG, a segment whose endpoints are in a circle, is a chord. Angle GEF. GEF, look at the middle letter, that's your angle. GEF, that is called a central angle. And the way I remember that is because its vertex is in the center of the circle, so it's a central angle. FDG, okay, middle letter, that's a vertex on the circle, is called an inscribed angle. Okay? Then it says a measure of angle FDG. FDG, we talked about that when we did, that's going to be 30 degrees. FEG, that's going to be 60 degrees. Remember, this is from our little circle experiment back in Unit 6. And the arc, intercepted arc, is going to be double what this is, the same as what this central angle is. So it's going to be 60 degrees. All right, let's keep rolling. Okay, next we have, it says measure angle F is 135 degrees. It tells us the measure angle G is 140 degrees. So I know that in an inscribed quadrilateral, the opposite angles are supplementary, means they add up to 180. So I could take 180 minus 140, gives me angle E, which is 40 degrees. Then I also know that these two angles, same thing. 180 minus 135 gives me 45 degrees. Right. Property of inscribed quadrilaterals. Next, how many common tangents does this have? Well, remember, a common tangent intersects each circle in one point and one point only. So I'm going to make this just real rough. There's one. Here's two. Here's 3. These are not perfectly straight. And here's 4. So it says 4 common tangent. All right, next, we have a few things to answer here. It says, well, let's assume that these segments CD and AD are tangent to the circle. So it says the measure of angle BAD, BAD. Well, I know that that's a right angle because tangent segment is perpendicular to radius, so this is going to be 90 degrees. The measure of angle ABC is 145, so that means this whole angle is 145. What's the measure of ADC? Well, these are supplementary, so I could take 180 minus 145 gives me 35 degrees. Next, it has AD. Oh, here we go. AD is 4. It says AB is 3. What's the measure of BD? Well, we can use Pythagorean theorem, right? 3 squared plus 4 squared equals c squared. You'll find out that this is going to be 9 plus 16, which is 25 equals c squared. Square root, c is equal to 5. So BD, this length, is going to be 5. All right, just a couple other things you want to know because they're going to ask you some questions about this. You know that the two radii are congruent, the two tangent segments are congruent, these two angles are both 90 degrees and congruent, so things that you need to know. Okay, let's keep rolling on. All right, it says find the area of the shaded region, and this looks like a slice of pie. Oh boy, that must mean it's a sector. When it says area like this and looks like a slice of pie, that's a sector area. And it talks about the length down here, that's the arc length. So we're going to do both of those in this case. And let me add on one little part that's not mentioned here. Let's just assume that this is 7 inches. Okay, so we have to have that number. So we're going to use, first of all, our arc sector area formula. So sector area over pi r squared, and our radius is 7, equals the angle measure 65 over 360. What you can do is just cross multiply and divide. So I multiply pi times 7 squared times 65 and then divide it by 360. So let's do that very quickly. And we get the sector area is approximately 27.8 square inches. Again, it's an area, so it's square inches. The arc length over 2 pi r, so I put in that 7 again. It's right here, equals 65 over 360. So do the same type of thing. I multiply 2 times pi times 7 from 65 and then divide it by 360 to get my arc length. So let's do that very quickly. I get about 7.9 inches, and that's inches because it's a length. Okay, let's stop right there, take a pause, and take a breath for a second before we go to the next video.